Welcome back, everybody. So, last week we had the crazy showcase of what we believe in alien self-portrait, or an alien selfie, basically. And, I mean, we've come a long way. We've come a long way from simply parroting numbers back and forth to literal visual representations of different concepts. But now let's go ahead and see what we're talking about here. So I'm still thinking about that last transmission. What in the world was that? It was so lengthy. Oh, right. New computer update. Now the compiler prints all the output signals at once. Aw, what? No more giant scroll. I love that part. Really? Yeah, it was great. Okay. I will push new update. It will do the full print for transmissions below 256 signals. Otherwise, it condenses. That's fair. You do that for me? You're the best, Batista. Okay, okay, no hugs. Too close. Alright, alright, I'll respect it. Right off the bat, we have a new signal. You know what I'm gonna do with that. You already know what I'm gonna do with that. Something 1 and something 2. Continuous. Something 6, continuous. Something 26, continuous. Is this the concept of infinity? Don't know. If we can just go back and see that. No, we can't. We can't. It was too cool. 17. Okay, anyway. So this is some sort of informational one again. So we're just saying what equals 0, but telling us something. Alright, what do we have here? With our trusty 1. And let's go count. One equals something count 1. 3 count what? And it seems to be 1, but I'm not quite understanding what we're talking about here. Let's just muddle through. It'll probably become clear in a future transmission. Okay, boom. We have a visual. Hey guys, check it. It's graph again. Dr. Bees, switch to visual tab. Come on, I want to see what they're drawing. Dr. Bees, you do as you wish. You are the leader of the team. No, check out visual. Die. Yeah, what are we looking at here? Tiny little thing. Zoom in. Whoop. Okay. Little tiny thing. I wonder if this is an atom or a molecule. Bum, 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 bum. Let's see. Atom. Atom. What do you need? No, I said atom. Dictionary. Look. Oh. Whew. We can talk about atoms with aliens. Dude, we can talk about the real world. Does that make sense here? So an atom. So what do you call the ones? I know somebody's gonna laugh at me. What do you call the ones that go around nucleus? Electron, right? A proton. Physics. Atom. Nucleus. Atom is the smallest unit of matter that contains chemical properties. Atom is composed of a combination of protons, neutrons, and electrons. Protons and neutrons are much larger and form the inner nucleus or core of an atom. The amount of protons and electrons So let's go back on our old transmission and think. We're talking about atoms. Maybe the question mark is electrons? I don't know. Let's just go question mark here. Oop, okay. I was gonna say, I thought that would be obvious. What count 1 equals atom 1? So maybe it's not atom. What count 1? Go back to the prior transmission. Something 1 count 1. Okay. You want like something 1. Okay. Okay, we're gonna muddle through again. Atom what equals... Oh boy. Getting interesting now. I no longer think this is atom though. Must be something else, right? Atom. Go back. Say 3. Okay, because it has 3 electrons, I think. 6. So it's 6 and 6 again. I can't quite tell if one of these is going to be proton and one is going to be electron. It would be atom 6, I guess. Okay. It's not atom, it's element, perhaps? No visualization on this one. And this is a damn mess. Let's go to the old dictionary. Object. Line. Recompile. Alright, so object 0. I mean, right off the bat, I feel like this has to be no space. 1 something. Is this word element? You know what I mean? Element something? Let's go all the way to the bottom. 9 and 17 and 35 and 53. Needs to be going, look at the pattern. So 6, 7, 8, 9, 14, 15, 16, 17, 32, 33, 34, 35, then 50, 51, 53, and 1, 2, 5, 1, 2, 4. I guess they don't want the and continuous. Or whiteboard. So variable 1, variable 0, sorry. 1, 2, variable 3. Equals. What is variable 0? Because I don't see that in here. It's way up here. Okay. Think about this, because why does it go from 1, 4 to 21? Follows the pattern, and then it goes 5, 6, 7, 8, 9. What does that mean? What the idea says. What is this? A hefty message, but it's not making any sense. We have 18 objects labeled 0 to 17. Why? Lumping a bunch of question marks together. Batista, is your calculator brain picking up on any pattern? Not math, it's something else. It's organized like a table. It isn't math, and what other starting points would aliens work from? What else do we have in common? Why is there 18 objects? Why 18 groups? The fact that holds the key. I'm gonna peruse the reference tab. Am I stupid? Do we... Oh my goodness, we have a freaking periodic table. The big dummy Dumbo. Neutrons, 0. Atomic number and atomic mass. Let's for instance, let's see, 1, 3, 11, 1937. I don't see those numbers here. Something else. See what else we have here. Reactions. Bonding. Wait a minute. They said we have 18 noble gases. Elements in group 18 have a full configuration of valence electrons, so none are shared. Makes them noble and do not form chemical bonds. Helium and neon. So what does that tell us? Let's go periodic table. Look at the gases, right? 1, 2, 3, 4, 5, 6. Quite remember how that works, but there's something about gases. One, 2, 3, 4. Just searching for patterns. Searching for patterns. Okay. Common compounds. Helium. Trying to see if any combination of numbers. Because this is 21 and 39 continued. Bum 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 bum. E39. atomic number 39. 21 anywhere on here. The other way. 21. Scandium. Is there 39 anyone here? No. Okay, I think we can kind of guesstimate, but let me... We already know it's going to be like this. Fans in there. In fact, it's one too many. So variable 0. But let's go based off of this. So it has 1, 2, 3, 4, 5 options. Whoopsie. These have 5 isotopes. 1. I guess helium itself and then 4 isotopes. Does that make sense? Don't know. If we're assuming that's true, then this would have 1, 2, 3, 4, 5 isotopes. Or 4 isotopes. 1, 2, 3, 4 including itself. Okay, wait a minute. Means this would have 2 isotopes. Now, see, that breaks the rule. What am I missing? Let's just go 1 up, right? So this would be 20. Assume that variable 0 would be 20. Variable 1 would be 10. Variable 2 would be 18. Lord, would it? I think variable 3 would be 18. The heck is variable? 1, 2, 3, 4, 5, 6 variables. 5. The last one that had 6 variables. 3, 4, 5, 6. Maybe variable 1 to actually actually 2 and 10 like that. Oh, does that make sense? Why I'm doing that? Let's try it out. No. Okay. What idea do they have for us here? Whoops. We got 2 at once. Alright, I got the first blank. Negative. Sorry, not negative. What am I saying? Question mark 37 is missing from group 1. No, they are 0 indexing. They begin counting at 0. Oh shoot, I've got to shift it over to group 2, so we're missing question mark 20. Just need the first 3 numbers of the final column. Nice. I have to reread that. I didn't quite understand what they're saying. Hold on. I found something. 18 groups. I found something with 18 groups. Check the reference tab. Which section? Exactly the periodic table. Yeah, I understand. I'm there. I get that part. Periodic table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 14, 16, 17, 18. Oh. Am I the dummy dum-dum? 1, 3, 11, 19, 37, continued. Okay, I am just stupid. I see. We're going vertically. These are the columns of the periodic table. Which means this is 4, 12, 20. Whoops. My bad. I don't want to send that out. But we had it kind of right. The variable 0 is 20, first off. Boop. Now let's go back. Means variable 1 is 2. Oh, did we just have it backwards? Yeah, and then 10. Then 18. Yeah. We kind of figured it out, but not the correct way. But I understand it now. What is that telling us? So question mark. So go back. That means that question mark is element. Looks like they like that answer. Element, as in an atomic element? Now that'd be something. If we can discuss elements, we open a whole new world of communication. That makes sense to me. Okay, cool. We got there. We got there. Oh boy. Okay. First off, we desperately need to shorten the word element. Just go for E for now. That won't bite us in the butt later, but okay. So, if the element variable count is higher element 1 variable count, then object 0 contains both. Oh boy. Think about that. Let's see what I have to say. We're dealing with E. Why is count here? Sorting the E, the elements, by frequency. By frequency is in abundance? Aha. Whoops. Just saw that page somewhere. Physics. No, chemistry. Common compound. No. Here we go. So, try and comprehend what they're saying. If the count of an element is higher than the count of another element, then the group has both. And if element 2 is less than element 3, then... Oh, so they're saying you rank it within the object. I understand what they're saying. Rank it within the object. Okay. So they're saying if 0 is greater than 1, you put 0 first. If 2 is less than 3, you put 3 first. Yes, okay. And they're going based off of quantity in the universe. This would be 1, 2, 8, 6, or what? 10, 26. Yeah, okay. Whew. That makes sense. Thank God for some of these ideas. And it's not 6. Because I need to put E. I'm a fool. Okay. We got there. Atom smaller. E near 0. Okay, so they're saying atoms are smaller than meteor 0. 8 to the 27th power. So atoms are smaller than one meteor by 8 to the 27th power. One atom equal to one meteor? The reference tab. I was looking through it and my goodness, you ruined the info I gave you. What is incorrect? Nothing's incorrect per se, but it's missing both nuance and cold hard facts. You ruined it. I tell you, you ruined it. Reference tab is not all explanatory. Having the essence is likely enough for us to progress. The definitions upset you experts to know well. An expert, you say? I like the sound of that. That's all it takes to get him off my case. I'm an expert, Dr. Alan Akers. Expert of astronomy and astrophysics. The charter of the skies, watcher of the stars, maestro of... He's still going. So I'm trying to understand this. So atoms are smaller than meteor 0. 8 to the 27th power atoms are still smaller than one meteor, is what I'm understanding here. So one atom smaller than one meteor. Okay. Sure. Bigger or smaller or area equals 2. Atom 1. What 1 atom 1? Bigger or area? Two atom 1. 2 atom 1. What 1 atom 1? You know what they're saying. Just go with 2 atoms are bigger than 1 atom. Okay. Okay, I'm still not totally caught on here, but I might be missing something. Dr. Batista, would it be alright if I sent you some information about linguistics? For the reference window? Yes. Sure, send it over. Okay, I'm hoping we're going to get an update that'll help clear this up a little bit for me. Bigger or smaller or area? Atom 4 smaller than atom 8. Ooh, wait a minute. Reference table. Physics. Atom. No. I was thinking, are they numbering the atoms? They're saying element 4 has an atomic mass of 7, and atom 8, which is an atomic mass of 16. So 16 bigger, so smaller. Could just be wrong. Could just be wrong still, but that's what I'm interpreting. Bigger or smaller or area. See, I don't understand what they're saying or area. Why are they using area like that? Makes me feel a little cuckoo for Cocoa Puff. Where's our area? Area. Be volume. Blowing over my head. Let me see what they're saying here. Our 3 options of this response are bigger, smaller, or area. When would we use area equals? Really? Never mind, I think I get it. They aren't bigger or smaller. Good. Yeah, but why are they trying to mean with area? Oh, they're saying it's both. The area is the same. The volume or the mass is the same. So I guess they're using area in this context to represent atomic mass. 1 what? Area equals 1 atom 10 area. Oh boy. Okay, let's see. Wouldn't it just be atom 10? So first off, not really atom, is it? Let's rename this to AN, like atomic number. Then let's fix the formatting. Let's what happens here. Atomic number 8 is bigger than atomic number 1. Atomic number 8 is smaller. It's 64 atomic number 1. 16 atomic number 2s. Okay. If I'm reading this correctly, let's see. Want chemistry periodic table. Atomic number 8 is an atomic mass of 16. Atomic number 1 has a mass of 1. Okay. 16 is smaller than 64, that's correct. So 16 atomic number 2s. So 16 times 4. How many atomic number 5s? So 64. Oh wait, that's 64. Yeah. 64. So atomic number 1, 2, 3, 4, 5. How many of these to get to 64? I guess 4 divided by 11? Work, does it? Okay, I'm making this too complicated. It's just bigger or smaller. So bigger. 16 atomic number 2s is bigger than 1 atomic number 4. Atomic number 5. Oh boy. Okay. Bigger or smaller? Atomic number 1, variable 0, 2. Atomic number 1, variable 0. Smaller. All kinds of screwed up math here. Let's look at formatting again. Variable. That'll make it a little cleaner. So atomic number 1. Desperately trying to understand. Let's go to atomic number. Bum, ba, bum, bum, bum. New line. See if that makes it any better. So atomic number 1, variable 0, 2. Atomic number. What the heck could that mean? Atomic number 1, variable 0, 2. I think isotope 2? Possibly? Boy, oh boy. Okay. Variable 0, smaller than atomic number 8. Variable 1, atomic number 2 atomic number 1s. Okay, bear with me, bear with me, bear with me. I think the dictionary's screwing us up here. atomic number 1, variable 0, 2 atomic number 1s. What does that mean? What does that mean? Variable 0 is smaller. Okay. Zero, 1, 2, 3. So first off, they want 0 and 1. The variable 0 is smaller than 2 atomic number 1s? Is that what they're saying? Oh boy. Getting tough now, folks. 2 atomic number 1s plus atomic number 8. Gosh. What's confusing me, I think, is the doubles. The doubles with this. I know it's going to be long, but I think I need it spaced out like this to make sense of this. So atomic number 1, variable 0. Desperately trying to understand what they're trying to tell me here. Okay, wait a minute. The brain is chugging. So here's my interpretation. You're given atomic number 1 and variable 0. These combine into 2 atomic number 1s. Meaning variable 0 is atomic number. I think. I think. So let's put that first in here. Atomic number 1. Now variable 1. So let's look at this. Given atomic number 8. Variable 1. Somehow find into atomic number. Look at the reference. Chemical reaction. Find 2 things. Composition. H2CO3 plus H2. Mm-mm-mm. I think we have this first one right. Second one is just thumpered. Eating with. How can it be atomic number? And this is saying atomic number 8. So oxygen comes 2 hydrogen. So oxygen plus something. Saying this is H. Well, no. 2HO. Dihydrogen monoxide. What does that tell us? I don't know. Desperately trying to understand. The biggest. Okay. Go back. Let's go from the 2 dashes to the 2 dashes. Whiteboard. Somehow, atomic number 8 and something atomic number. Just don't see how that's possible. I just don't see how it's possible. Reference chemical bonding. Chemical bond. Valent bonds, ionic bond. Alec bonds. Hmm. Okay. In a chemical reaction, if 2 molecules are needed to balance the equation, this is represented by 2H2O. Common compound. Here we go. Here we go. Really trying to understand. Bigger or smaller? Bigger or smaller? Bigger or smaller? Gosh, I feel like we're just so close. Really do. I really, really do. Two. Just don't quite understand this. Because we're saying two hydrogen. A hydrogen gas. Like hydrogen versus what? Hydrogen versus what results in hydrogen gas? The question? Your brain. Use your brain. Brain. Hmm. Because two and one. Hydrogen gas. What does that mean? And look at this ending piece. Hydrogen. Oxygen plus whatever this is. 6. Then one carbon plus two oxygen. So carbon. Okay, wait a minute, wait a minute, wait a minute. Bigger or smaller? Smaller. What is smaller? Variable 1 is smaller. Variable 0 is smaller. Hmm. Alright, well listen, I don't want to waste a bunch of time for you guys. I think I might put another cut in here again. Because I just want to sit here scratching my dome. I feel like I'm close. Clearly, this is hydrogen gas. Hydrogen gas. And then, if I go to reference, compounds, common compounds. So something that combines with one hydrogen, is that what it's looking for? That's smaller than hydrogen gas. hydrogen. Aluminum, 1 copper, potassium, 1 hydrogen, 1 chlorine. Could be that. Could be that. Yes. Hydrochloric acid? Does that make sense? But a liquid is lighter than a gas? That can't be true. Bigger or smaller? Bigger or smaller? Mm-mm-mm. Alright. Yeah, I'm going to put a cut in here, folks. And hopefully when we come back, we'll scratch the noggin. Probably try a few things, maybe see if an idea pops up, and we'll go from there. So thanks for watching. See you next time.